You can find the formula of an ionic compound in a much simpler way using the oxidation numbers of the atoms involved. And in this case, aluminum has an oxidation number of +3, iodine -1. In fact, we really don't even need the signs for this. One thing you'll note is that you always have a positive and negative when atoms are bonding ionically, and we always write the positive part first, but it's really just the number 3 and 1 that we need to use to write the formulas. We call this method the crisscross method because that's what we do with the numbers. We crisscross them. So aluminum has a oxidation number, which is technically the valence that we're using, but of 3, and iodine of 1. So we crisscross those numbers and we give aluminum 1 and iodine 3. And so we write it Al. We don't put the 1 because it's just like in math with 1x, we just write that as x. Well, if we have Al1, we just write Al. But anyway, so Al, I3, and that's the formula. And it works like that pretty much all the time. I'll show you the one place where there's an exception to it, but otherwise this is going to work for writing formulas. I don't teach you this in the beginning just because I really want you to understand what's happening, but this is the way that we write formulas. Okay, the next one, calcium chloride. Calcium has an oxidation number of 2, chlorine 1, and so in the formula we have 1 calcium and 2 chlorines. And that's because, remember, calcium 2+ means that calcium is going to give up 2 electrons. It takes 2 chlorines to pick up those 2 electrons, and so the formula is, ACaCl2. Okay, the same thing's going on with potassium sulfide. You can look at that. And then magnesium oxide is where this breaks down a little bit. In the case where you have both of your ions, both the positive and negative ion, have the same charge, although it's the opposite charge. So magnesium has an oxidation number of +2 and oxygen -2. Then what happens, if you remember back to the electrons, that means magnesium has 2 electrons that it can give up and oxygen needs 2. And so it only takes 1 magnesium to give its electrons to 1 oxygen. So the formula then is just MgO, so it's just 1 of each. The formula would be reduced, as in math, with a fraction. You might reduce a fraction. It's kind of the same thing. If you write Mg2O2, I will in fact take off at least half the credit. But you see, you don't want to do that. If they're both 2, if they're both 3, same thing.